In this video, we're going to take a look at section 3.2, addition and subtraction of whole numbers. And in particular, we're going to be looking at one-digit whole numbers. In class on Tuesday, we'll expand that to two-digit and three-digit whole numbers. So the definition of addition is based on the idea of sets. If set A contains A elements and set B contains B elements, and A intersection B equals the null set, then A plus B equals C is the number of elements in A union B. So addition was defined using sets, and in this particular case, our sets A and B don't have an overlap. So we could just take the number of elements in A plus the number of elements in B, and that would give us the total number of elements. When we look at the equation A plus B equals C, the A and B portion of that equation are called the addends. The two numbers we're adding together are called the addends, and the answer we get, C, is called the sum. When students are in the elementary grades, they'll be doing lots of problem solving, and one of the things that they're going to need to do is they're going to need to identify what the operation is. So there are some keywords that indicate that we're going to be adding. Here we can see words like total, join, altogether, both, sum, increase, combined, plus, in all, and add. These words indicate that you will most likely be adding. There are some situations where altogether could mean something a little bit different. For basic word problems, though, we can use those words to indicate that we're going to be adding. A little history, it wasn't until about 1498 that the actual signs for addition and subtraction came into being, and that is thanks to a German mathematician by the name of Whiteboard. In this chapter, we're going to be looking at whole numbers, and as we progress through our chapters, we're going to look at different sets of numbers. We're going to have our whole numbers, we'll move into integers, and then we'll go into our rational numbers, and then our real numbers. So with each of these, we're going to be testing out several properties. And for addition, one of the properties that we're going to look at is the closure property. We're going to test to see if the closure property holds. The closure property says that if A and B are whole numbers, then A plus B is a unique whole number. So basically what closure means is that whatever number system we're looking at, if we perform that operation, we'll still get an answer that's inside or contained in that set. Closure requires that the operation on two members of the set results in a unique member of the set. So it has to give you a unique answer. It can't be a repetitive answer. So if we were to go ahead and test out the even numbers, our even numbers close under addition. So if we think about our even numbers, we're looking at 2, 0, 2, 4, 6, 8, keeps on going. So basically, what we want to check is that if we add any two even numbers, do we end up with an even number? So if we take 4 plus 6, we get 10. That's even. If we take 2 plus 4, we get 6. That's even. If we take 0 plus 8, we get 8. That's even. It looks like any way we arrange or add these numbers together, we're going to end up with a unique answer. So 4 plus 6 is going to give us 10. And we end up with something that is even, which would be in that set. So we would say that even numbers are closed. Even numbers are closed under addition. So then we can check to see if that is true for odd numbers. So if we think about our odd numbers, we're looking at 1, 3, 5, 7, 9, 11, and it keeps on going. So if I was to add any two odd numbers together, 3 plus 5 is equal to 8, 7 plus 9 is equal to 16, 1 plus 3 is equal to 4. When I do that, I notice that I'm getting an even, even, even. I'm getting answers that are not odd numbers. They're not in my set. So because of that, we would say that odd numbers are not closed under addition. So they are not closed. So in order for a set to be closed, they would need to have, when we add the numbers together, the sum would need to be in that particular set. We'll look at some practice problems on Tuesday. It's important when we're teaching our students some application problems or practicing application addition problems that we show them a variety of different forms. With addition, there's just two forms. We have combining groups and we have combining measures. With combining groups, we're just looking at groups of items. So in the example, John has 3 goldfish. We're just combining the number of goldfish, 3 plus 5. So a group of 3 and a group of 5. When we talk about combining measures, we're looking at a measurement. So in the second example, we have Ellen weighed 105 pounds and she gained 5 pounds. So we're looking at a measurement of pounds. So just remember, with the application problems, we want to be sure we're exposing students to both types of addition applications. In the early grades, when students are learning one-digit addition, they're going to learn a variety of strategies. In preschool and kindergarten, students typically count all. So if they have objects that they're trying to combine, they would just put all the objects together and count them all. In the example that we see here, we have 3 fingers and 4 fingers. So a student would count this as 1, 2, 3, 4, 5, 6, 7 to get their total. They would just be counting and touching each item and giving a count for it. Right around the middle of first grade and moving on to second grade, students can understand the idea of counting on. So counting on is different than counting all because you're not going to count every single item. You're going to start with the biggest number and then move on from there. So in the example we see here, we're looking at the number 4. We have 4 plus 2. So they're going to look at the number 4 and they're going to think about 4 in their head, and from there they're going to count 2 more, 5, 6. So if we had something like 7 plus 3, the student should think about the number 7 in their head, and then they're going to go 3 more from there. So 8, 9, 10 to get their answer of 10. So counting on is the ability to start with the largest number and then move on from there. Counting all is where we count all the items in the set. In second grade, students are responsible for learning the addition facts, one-digit addition facts. It's in our content standards. They should be able to fluently add and subtract one-digit numbers. So a variety of strategies are put in place to help students with this. The first one is plus ones. So they can think about being on a number line and just moving one spot over on the number line. So typically students would, if they're given a number like 3 and it was a plus 1, they could just do one hop on the number line. It's just like counting. Then they learn the plus 2s. Plus 2 is like skipping 1 when you're counting. So if you had 3 plus 2, I know the next number is 4. I'm going to skip that and go to the next one and get 5. Another strategy they learn early on is the plus 10s. If they are learning about place value, they know that if they add 10 to a number, they're actually going to be adding 1 to the tens place. So they typically will learn all of their plus 10s. So 3 plus 10 is putting a 1 in the tens place, and I have 3 ones. If I look at 5 plus 10, that is, I have 1 group of 10 and 5 ones. And so they can grasp those concepts pretty quickly. Another concept that they learn pretty quickly is doubles. They typically look at different sets or things that they're familiar with to learn their doubles. So the doubles of 5 plus 5, they can look at their hands and see that 5 plus 5 is 10. They might look at the doubles fact 8 plus 8. If they have a crayon box that has 16 crayons, it's divided into 2 groups of 8, so 8 plus 8 is 16. If they're looking at an egg carton, they would see that they have 6 plus 6 is equal to 12. So the doubles facts are taught early on in learning their addition facts. Once they have these 4 strategies for facts, they can kind of use those strategies to help them find others. So once students get really good with the doubles, they can go into a near double. So a near double is something that's close to a double. So 7 plus 8 is really close to 7 plus 7. It's just one more. So if they know the 7 plus 7 fact is 14, they know that 7 plus 8 will give them 15. If they had the fact 5 plus 6, they would know that that's near the double 5 plus 5. It's just one bigger. So 5 plus 5 is 10, and one more is 11. Once they've gotten a good grasp of the near doubles, they can move on to the near doubles, which would be something like 7 plus 9. So it's not next door neighbors to 7, so 9 is not the next number, but it's one more over. So it's like they're 2 houses down. So we can think about it as, well, this is a double, but 2 more added on to it. So I have 14 plus 2 is 16. I could look at 4 plus 6. That's near, it's 2 away from each other, so I know that 4 plus 4 is 8, and I can add 2 more to that to get myself 10. The last strategy is the near 10 strategy. The near 10 strategy is going to use the idea of 10, but we're close to it, so we're looking at the plus 9s really. So this is plus 9s, and it'll just be 1 less than my plus 10s. So if I looked at 9 plus 5, I would say that that was really 10 plus 5, which I know is 15, and then I would take away 1, and that would give me 14. So these are many of the strategies that students are learning in grades 1, 2, and 3 so that they can become fluent with their addition facts. We're going to move on to subtraction. Subtraction, you'll notice in the definition, is linked up to addition. For any whole number a and b, a minus b equaling c, if and only if a is equal to b plus c for unique whole number c. So we can see that a minus b equaling c is connected to the fact that a is equal to b plus c. So we're relating the two, and we have this if and only if saying that this is true in both directions. If I have a is equal to b plus c, then I know that a minus b is equal to c. So some key terms here in the subtraction equation, a minus b equals c, the letter c is called the difference. So the answer we get in the subtraction is called the difference. Some keywords that mean subtraction for us are how many, left, subtract, remain, minus, decrease, fewer, shorter, farther, take away, difference, less than. So we have lots of different words that we can use to indicate subtraction. In the early grades, subtraction is introduced to students in the form of a diagram. So here we have a diagram with information. We have Ellen had 14, so that was her total, her whole, and she gave Callie 8, and we want to know how much she has left. So she has 14, she gave away 8, how much does she have left? We can, in this format, we can link this up to addition. 8 plus how much is going to give me 14, and then write it as that subtraction. So the subtraction diagram allows students to link it up to addition. I have 2 numbers that are going to make my whole. Subtraction is an inverse operation of addition, so it undoes the addition. And here you can see how that looks. We have 6 plus 4 equals 10. When we invert that, we get 10 minus 6 equals 4. So we have, we're able to link the 2 operations that undo each other. With subtraction application problems, we have a couple of different scenarios or classifications. The first one is the traditional takeaway. So when we are given a problem and it's set up in the problem, it sounds like we're just removing something. In the example, we have Sarah had 8 candy bars, she ate 2. So we could visualize she had 8 and she's taking away 2 of those. In the second type of classification, we have compare, and compare involves 2 groups that we're making a comparison to. So we have Max is 51 inches tall, Sarah is 47 inches tall. How much taller is Max? So with the comparison, it'll be things like how much taller, how much shorter, how much longer. And in the missing part, we know one part and we're trying to figure out the other. It's supposed to take the Mareka family 9 hours to reach their vacation destination. So you can almost think of the subtraction diagram. We know what the whole is at 9 hours. They've been traveling for 5 hours, so we have that one block below it filled in. How many more hours will they have to travel? What is that missing piece? So we're given the end, and we have one piece of it. We need to find the other that'll give us that whole. So all 3 of these classifications can be broken down into groups. So in example 1, we have a group, and then in example 2 and 3, we have them written down as measures. We could also do comparisons of groups and comparisons of missing parts. And the last piece of notes I want to share with you today are just methods we have for single-digit subtraction. And we have a couple of different strategies. The first strategy we see here is drawing a picture. And in drawing this picture, we're able to do a takeaway where we cross out and count what's left. So for 9 minus 3, we could take away the 3, cross them out, and count what we have left. Another option we have here is counting up. So I have 6 plus something is equal to 8. So I can count how many numbers I need to get to get to 8. So from 6, I have 7 and 8, which is 2 numbers. Another option we have is counting backwards. If we have 4 take away 2, we can just count backwards. So I'm at 4, I'm going to go 3, 2, and that puts me at 2. We can invert our doubles facts, so we know that 4 plus 4 is 8, so 8 minus 4 will be a doubles fact. We can look at related facts, and we'll talk about those related facts in our fact triangles. I know that 7 minus 2 is 5, so I can interchange that 5 and 2 to get my second fact. We see a lot of times students are using the draw the picture quite a bit, and then we also rely on the number line. So for 10 minus 4, students would start at 10, and they would just count backwards on the number line to get to 6. Tens frames are used as well. With the tens frame, we could color code to make addition facts, or we could color code to do a takeaway. Here we have 10 take away 2, so we're removing 2, and we'll get 8 left there. We already talked about the part to whole diagrams. The part to whole will allow us to think about an addition fact. So 5 minus 3 allows us to think about 3 plus what number will give us 5. And then if we use counters, with counters we can physically move them and remove them. So here we have 10 minus 5. We would take this group of 5 and move it away. Students in first grade spend a lot of time using 10 frames, and in kindergarten as well. They think about all the different ways that they can make 10. So a tens frame, we can see right here, is really just a rectangle divided into 10 with a row of 5 and a row of 5. And students will use counters or other types of manipulatives to fill in the squares to help them count and group tens together. In this example, we can see that we actually have a couple of addition problems here. I have 4 plus 6 is 10. I have 5 plus 5 is 10. And I have 6 plus 4 is 10. I could think of it as a takeaway. I have 10, and I'm turning over 4 of these reds, which leave me with 6. I have 10, and I'm turning over 5 to red, and so now I have 5. So tens frames are used a lot. It's really helpful for students to know how to make tens. It'll help them later on with other strategies we have for addition and subtraction. As students learn their addition and subtraction facts, we try to link them together, and so we use these fact triangles. The lower 2 corners of the triangle are the add-ins, and the top number is our sum, and then from that we can write out several different addition and subtraction facts. So if I was to have a triangle, this one here's a special case because we have 6 and 6, which gives us 0, but if I had a triangle like this and my numbers were 4 and 3, I would put 7 up at the top, and then it will allow me to write some facts. I would add 4 plus 3 equals 7. I could add 3 plus 4 to give me 7. Those are my two addition facts. I can also write subtraction facts. 7 minus 3 will give me 4, and then 7 minus 4 will give me 3. And this is what we would call a fact family. On Tuesday, hopefully we'll have a little bit of time to look at some Marcy Cook math pages where she uses 10 digits to solve a whole bunch of problems. So hopefully this was a good quick overview of addition and subtraction strategies. We looked at some application problems. We talked about some different manipulatives that are used. And on Tuesday we will go through these ones pretty quickly and then move into double-digit addition and subtraction and looking at those strategies. Please go to Moodle to find the Nearpod with some questions about these notes.